Okay, so we're in Unit 10 here. We're in area, perimeter and volume. We'll first of all take a wee look at compound shapes. So calculate the areas, calculate the perimeter of compound shapes. Nice straightforward one for us here, certainly for GCSE, but a wee bit of working out to do. Obviously we want to find the area and perimeter then of the following shapes. So a couple of wee sides we need to be able to work out the length of. So if I draw my line across here, we know that's 11 and that's 15, so it means that that there needs to be 4. That's 10. That's 13, so that's going to have to be 3. So if we do Pythagoras for that, you might even recognize those numbers. So that's just for this wee side here, because we need this length here for the perimeter. Obviously, if that's 3 and that's 4, I label my sides in A, B and C. Then C squared equals A squared plus B squared. C squared is 16 plus 9, C squared is 25, and that gives us then that C is going to be 5. That's a Pythagorean triple. 3, 4 and 5 work for Pythagoras theorem, so that will help us then with that wee bit. So for our perimeter, it's going to be, where do we start from? Let's start from here, 11 plus 13 plus 15. This takes us up to there, plus 5 and plus 10. So I'm sure we can work this out. The 15 and the 5 give us 20. That gives us 30. That gives us 41. So that's going to give us then 54 centimeters. I hope that's right. For our area, we're going to split it up into 2 shapes. We're going to do length times breadth plus a half the base times the height. For area 1 here and area 2, that would be the area of 1, that would be the area 2. So that's 13 times 11. 13 times 11 gives us 143 centimeters squared. Then half the base times the height, so base times height is 12 divided by 2 is 6 centimeters squared, so we have 149 centimeters squared. A wee bit then on circles, really stuff from year 9 effectively, but find the circumference of a circle with radius 5 centimeters. We're going to see is 2 pi r. C then is 2 times pi times 5, which is 10 pi, which we go for 3.14. Sorry, 31.4 centimeters. The 3 significant figures are 2 decimal places. The circumference of a circle is 34 pi. Find this radius. A slightly unusual one here because they've given it in terms of pi, but if we have C is 2 pi r, that means we have then that 2 pi r is 34 pi. If we can divide both sides by pi, that cancels that. So we have 2r is 34, and that means that r is going to be 17. There's no unit given in this, so we don't have any unit in there. Areas then, so area is pi r squared. So area is pi multiplied by then half of 19.3. I'm sure I should be able to work that out in my head. 9.65 is 9.65 squared. And multiplied by pi, then we are getting 292.55. 2 decimal places. And that then is centimeters squared. Okay. The area of a circle is 49 centimeters squared. Find its radius and therefore its circumference. So we know that area is pi r squared. So we know pi r squared in this case is 49. R squared is 49 divided by pi, and then r is the square root of 49 divided by pi. So let's see what way we'll do this in the calculator. If we go for 49 divided by pi, and then if I take the square root of the answer, it's giving me 3.95. So my radius then is 3.95, and then they want the circumference. Hopefully you can see that okay. C is 2 pi r. C is 2 multiplied by pi multiplied by 3.95. Although good to keep the number in the calculator if you can. I still have it from the previous calculation, so you can see it's in there. It's going to give me a more accurate one. So I'm going to times that by 2, and then times it by pi, and that give me 24.81. And that then would be centimeters. Area of a circle or length of an arc. The length of an arc obviously is a wee part of the circumference. The length of the arc is AOB, which is our angle, over 360 times by 2 pi r. And so we can find then the information required, kind of using any of the information. I wouldn't tend even to use these formulas. It's an awful lot to remember. I always think if I'm trying to find the size of a sector and I know the angle, what would I do? Find the little circle, find 1 degrees worth, so I divide by 360 and then multiply whatever by whatever the angle is. But either way works, whatever way you fancy doing it. It's just another formula that we need to kind of learn. So find the area of the sector here. Using the formula they have is 96 over 360 multiplied by pi multiplied by 15 squared. So I think, goodness, I'm messing up here. It'll start again. 96 divided by 360 equals 4/15 times by 15 squared gives 60, multiplied by pi is in 60 pi, or 188.4, 188.5 actually, centimeters squared. Arc length is going to be 96 over 360 multiplied by 2 multiplied by pi multiplied by r. So again, that's 96 divided by 360. I'm going to multiply it by 30, which I think is going to give me 8. So the answer then is going to be 8 pi. Which then is 25.1. That then is centimeters. As I say, you don't need to do it that way. If you want, find the whole circumference, divide by 360, which would give me 1 degrees worth. I always think about it as like the finest little slice, kind of 1 degrees worth, and then times it up by 96. That should work then for us. Calculating the angle in a sector. So let's take a look here then. To calculate the angle in a sector, we use the formula for length of an arc and area of a sector to work backwards. The length of the arc AB in the center of the circle, radius 12 is 16.75. Calculate the angle. So what are we going to do? So the length of our arc is 16.75. This is using this formula, which is going to be x, which I'm calling my angle, over 360 multiplied by pi multiplied by 2 multiplied by 12. So let's start to tidy some stuff up here. So we're going to have 24 pi over 360. If you want 2 times 12 times pi, so if you want 24 pi over 360, x is 16.75. Again, there are other ways of doing this, and if we then do 16.75 then divided by this number here, I think that should work out nice and easily for us. 24 divided by 360, of course, then is a 15th, so it's pi over 15. So if we do then wait a minute, I'm getting myself confused here. So it is 24 divided by 360 over 15. So it's going to be pi over 15, and if we want to divide by that, so we're going to do 16.75 multiplied by 15, and then divide by pi is 79.98. You effectively can get a number for this, and then divide it into this. I'll give you your angle, then it's 79.98. Part B, the area of the sector then, so our area is 79.98 over 360 multiplied by pi r squared. So divide my previous answer then by 360 multiplied by 144, which is the 12 squared, multiplied by pi. This thing gives 100.5, and that's centimeters squared. Example 2, the area of a sector which subtends an angle of 104 degrees at the center is 52 centimeters squared. Calculate the length of the arc in this sector. So we're given our angle here, we're given our area, so we need to work out a radius then from that. So our, just do the wee formula again. Area of sector is angle over 360 multiplied by pi r squared. So we know that 52 is 104 over 360 multiplied by pi r squared. Again, a load of different ways of doing this. We can do this and work it out, find the pi r squared, then divide by pi. That would be fine, but let's just see. So if I go 104 divided by 360, 13 over 45, so we do 52. So that's going to be 180, so 180 then divided by pi. 57.296, so that means my r squared is 57.296. So what have I done there? I've got this as a number, and I've divided it into that, and that's given me then my 57.296. Obviously then to get my r, we will then get 7.569. They want the length of the arc, so arc length is going to be then 104 over 360 multiplied by 2 multiplied by pi multiplied by r. So times by 2 equals times by pi equals times by 104 equals divided by 360 equals, and I get 13.74. That's then in centimeters. Example 3, find the perimeter and area of the following shape. Correct the three significant figures. So perimeter, first of all, hopefully you can see then this is going to be half a circle. So let's pretend then it's a full circle. So we go full circle first of all, and then I'll just divide it by 2. Full circle is pi d. And so in this case then it's going to be, there's a 10, which is my diameter. So that's going to be 10 pi. Therefore half circle is going to be 5 pi, and if I keep it then as 5 pi, I can do it to three significant figures in a wee second. Therefore, perimeter equals 20 plus 10 plus 20 plus 5 pi. And now I can put that in the calculator, because this is going to be 50, and just add them to the 5 pi. We can keep it nice and accurate. So it's 5 pi equals plus 50 65.7. Sorry, just a wee bit of hassle with the computer here. So 65.7 centimeters. So that's a perimeter. And if you can see that again in terms of our area. Full circle is going to be pi r squared. So the r is going to be 5, so it's going to be 25 pi. Therefore, half circle is going to be 12.5 pi. The area of this shape then is going to be 10 times 20, which is 200. Therefore, total area is 200 plus 12.5 pi. And again, let's get this into three significant figures. 12.5 pi equals plus 200 equals 239. The three significant figures. That's going to be then centimeters squared. Okay. Perimeter and area of other shapes. Calculate the area of the following parallelogram. Couldn't be more straightforward. It's going to be 15 times by 8. Area is the base times the height. So it's going to be 15 times 8, which I think that gives us 120 centimeters squared. Another nice straightforward one here. Our base is going to be 5 and our height is going to be 14. This 16 then is just like a red herring. So area is then base times height. So area is 5 times 14, and that gives us 70 centimeters squared. And again, we just need to be a wee bit careful with this one. So if they've given us this as the perpendicular height, then this must be the base. 147 times 53. Now, 53 times tables aren't what they used to be, so we need a calculator for this one. 53 times 147. 7791. 7791. And that then is centimeters squared. Trapezium, a half a plus b upon h. So the area in this case is a half, and the a and the b are the two parallel sides, so it's 9 plus 5. And then that's times by 7. Plus 5 is 14, so 49. Let me just check that, I don't quite trust myself. 9 plus 5 is definitely 14. Half of that is 7. 7 times 7. Yeah. Volume then, you should be able to find the surface area of cubes and cuboids, blah 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 blah. Length, base, height, that's okay. The volume is given by LBH, and the surface area, hopefully you understand this one, so hopefully you can see, right, there's two of these, there's that one on the top and the one on the bottom, and that's length times B, so that's why there's two LB there. That's the top one and the bottom one. There's 6 faces, and that's me kind of working them all out then from there. So find the surface area and volume of a cuboid. So surface area is going to be 2 upon 5 times 7 plus 2 upon 7 times 12 plus 2 upon, what will I have, 5 times 12. 5 times 7 is 35, so that's 70. 7 times 12, what's that, 84, so it's 168. And 5 times 12 is 60, so that's 120. I'm sure I trust myself to add that in my head. So 70 plus 168 plus 120 gives me 358. And that then, are we in centimeters? We are, so it's centimeters squared for area. Volume's nice and straightforward. Is LBH, and length is 5 times 7 times 12 7 times 12 is 84, times by 5 then is going to be 420. And that's centimeters cubed. A cuboid has volume 135. Its length and height are 9 and 5. Find A its breadth and B its surface area. So we're going to do 135 divided by 9 times 5. Hopefully that makes sense. So this times what? With times its breadth, then it's going to give us 135. So that's obviously then 135 divided by 45. So it must be then 3. Our surface area, very similar then to our last question. We're going to go for 2 upon 9 times 5 plus 2 upon 3 times 5 plus 2 upon 9 times 3. 9 times 5 is 45, so that gives me 90. 3 times 5 is 15, that gives me 30. 9 times 3 is 27. 2 of those then are going to give me 54. 120 then 174 centimeters squared then must be that. Volume of a prism, again another thing really just from Key Stage 3. A prism is a three-dimensional object with a constant cross section. The volume of any prism is given by the volume cross section area times length. Find the volume of a prism. Base area 59 and length 9.3, so we would do 59 times 9.3. And that gives us 548.7. That'll be centimeters cubed. Find the surface area and volume of the following prism. I've done a wee bit on this one here, but we're going to go back to the start so I can try and get my head around what's going on. So surface area, first of all, we are going to have to find this wee length here, first of all. So we are going to do you know what, I'll do volume first. So this is a prism. The prism then, this is the surface, so we need to find the area of that. So that's a triangle, so we do 20.1 times 15.2 divided by 2. That's what I've done there. Once you find the area of that front face, you just times it then by 18.8. And that then gives us our answer. So hopefully you see, even it's a bit messy looking where that has come from. So let's put this into our calculator and see what we have. So it's going to be 0.5 times 20.1 times 15.2. I'll hit equals now just to show you. So that gives 152.76. That's the area of this front face here. We're times it then by 18.8. To give us 2871. So if we go just to the 4 significant figures, 2872 centimeters cubed. Alright. For the surface area, it's a little bit more messy, so we need to find this length here. So we're going to have to do Pythagoras. So we're going to go, let's do a wee title here. This is the surface area we're starting to work out. So first of all, for Pythagoras, c squared equals a squared plus b squared. C squared is 20.1 squared plus 15.2 squared. So it gives me 635.05. C then is going to be the square root of that. Be nice. No, close enough. 25.2. And because that's the right angle in there, now I've put the right angle in there, I'm assuming it is, otherwise it can't be worked out. So we then have a 25.2 here. So in terms of our surface area, we have 5 faces to work out. Let's work our way through them. Oh, you can't even see that. I'm sorry about that. Okay, hopefully we're all up to speed in terms of what I've done there. I don't know if it was on the page or not, but anyway, this length here is 25.2 centimeters. Our surface area then is going to be this triangle times by 2. So it's going to be half 20.1 multiplied by 15.2, this one, but of course then there's two of those. Now if you do something and you divide it by 2 and then you times it by 2, you just get the same thing, so that sum shouldn't be too bad. If we just do 20.1 multiplied by 15.2, and we end up with 305.52, so that'll be a bit. Right, what else do we need? We need our 3 rectangles. So this one's going to be 25.2 times 18.8. This one's going to be 15.2 times 18.8. And this bottom one then is going to be 20.1 times 18.8. Which shocking working out here. But we'll see how we go. 25.2 times 18.8 gives us 473.76. 15.2 times 285.76. 20.1 times 18.8. 377.88. And if we add those 4 values together, what exciting number they're going to come up with for us. Plus 285.76 plus 473.76 plus 305.52 equals 1442.92, and that then is centimeters squared.